This is part 3 of our lesson on vector addition and subtraction. We just did a question where we added two vectors together by drawing them as carefully as we could. And we are now going to talk about how we could do it using calculations instead. And we're going to do it two ways. This time in this video, we're doing it with cosine law. And in our last video, we will do it using components or the sine, cosine, tangent ratios. So it is the same question. It says determine a plus b if the magnitude of a is 5.2 centimeters, the magnitude of b is 7.2 centimeters, and the angle between the two vectors is 40 degrees. So this time we're going to try to do it with trigonometry. We're not going to measure and use, a protractor and a ruler. So I would still like to have a rough diagram to work with. It doesn't need to be perfect. I don't need to really measure. I'm just going to randomly draw a vector A just so I have something to work with. Roughly 40-ish degrees. Vector B is a little longer. So this is A, this is B, this is 40 degrees. All right, I didn't use a protractor. I didn't actually measure anything. I just kind of drew two vectors. I know A is shorter than B. So what we're going to do is slide this vector over. I'm going to slide it over here and then redraw it so that it now lines up with the head of vector A. So as I mentioned in the previous video, when you are measuring the angle between two vectors, it is always when the vectors are tail to tail, right? But when I'm adding them, they have to be lined up head to tail so that they make a continuous path from the start to the finish. So my resultant is going to be here between the tail of A and the head of B. Okay, I'm going to label on some information from the question. It told me the magnitude of A was 5.2 centimeters. It told me the magnitude of B was 7.2 centimeters. So that's useful. And I knew that that angle there in between those two was 40. Now, A, B, and the resultant have made a triangle here. And that's the triangle that I want to try to use and solve. Now, when I have two sides, I can find a third side using Pythagorean theorem if it's a right angle triangle. But this is not a right angle triangle. That is not 90 degrees. So what I'm going to need to do is figure out what this angle here is. And this angle here, these two B's are pointing in the same direction because they're the same vector, which means that they are parallel. So this line, which is called a transversal, that intersects those two parallel lines, creates a C pattern. Angles in C pattern always add to 180 degrees. So 40 plus this angle should equal 180 degrees, or I can calculate this one by doing 180 minus 40 degrees, which is 140 degrees. And that is, in case you are interested, C pattern. So this is 140 degrees. Okay, so I have this highlighted triangle. I know two sides. I now know one angle, and I would like to find the length of this side. So since this is not a right angle triangle, I could try to use sine law or cosine law. To use sine law, I need to have an angle and an opposite side that I know both numbers for. The angle that we know is this one. I don't know its opposite side. I know this side, but I don't know that little angle up there. Sorry, my computer is telling me it really wants me to restart. So I'm telling it to go away. There we go. And then this side we know, but then this angle, I know the whole thing is 40, but I don't know how much this is. And it's not just half, by the way. It's some fraction of it, but I don't really know how much it is. So sine law is not going to work here, but cosine law would. Cosine law works when you have two sides and the contained angle or the angle in between them. So cosine law is a squared equals b squared plus c squared minus 2bc cos a. Now, that means I have to label my sides A, B, and C. I need to label the angles. So in my picture, the angle that I have should be my A. So I know I have vectors listed already. I maybe should have used some different letters here. This angle is the one that was given, well, the one that we calculated. So that is going to be my angle A from the cosine formula, which means across from that is side A. And then B and C, it's up to you. This one's already B, so why not keep it B? And then this one is going to be my C. This would be angle B over here, and this would be angle C over here, but I don't currently need those in order to be able to solve, but I could label them anyways. Okay, so if I'm using my cosine law formula, side A is this side, which I don't know. It is A plus B. So I could leave it, honestly, as just A. I could write it as the magnitude of A plus B because it's the length of that side. So the magnitude of A plus B squared equals B, that's this side, 7.2 squared, plus C, that's this side, 5.2 squared, and then minus 2 times B, 7.2, times C, 5.2, times cosine of A, which is 140 degrees. Okay, I strongly recommend doing all of it in one step on your calculator. I don't know what I just said. You don't have to, but I make fewer mistakes if I just do it in one big, long calculation. So I'm going to do 7.2 squared plus 5.2 squared minus 2 times 7.2 times 5.2 times, and I'm already in degrees, so this is good, cosine of 140. So I have to do 140 cos because of my calculator. Equals. And I'm going to write the whole thing down. This is not my final answer. We are not going to round. So I have 136.2414079. All right, this is not the magnitude of A plus B. This is the magnitude of A plus B squared. So to get rid of the square, we would do the opposite and square root. Now, we all know that when you square root as part of your solving, you are going to get two answers, a positive and a negative. However, we are calculating a side length, so it doesn't really make sense here to get a negative answer. So we don't usually put in the plus and minus when we are doing cosine law. But just so you know, it is there. We would just have to throw that answer away. Okay, I'm going to take this and I'm going to square root. And I get approximately 11.67. That's going to stay 11.67. Now, it didn't say in the question to round to 2 decimal places, and it should have. My apologies. So that is approximately 11.67 centimeters for the magnitude part. And then I have to calculate the angle. Which angle do we want to calculate? We want to calculate the one that it makes where it's tail to tail with another vector. And it is tail to tail with A here. So this is the angle that we want to find. That was the angle we found last time. I think I might call that X for now. We could call it theta if you want, be a little fancier. All right, in order to do this, I am going to need to at least fill in this information up here. So this is 11.67. So I have a choice between sine and cosine law. I could use cosine law with X because I know all three of the sides. So I could solve for angle x using cosine law. I could also solve using sine law because I now have an angle and an opposite side. I have that 140 and that 11.67, and I could do it with sine law. Now, the problem with sine law is that if it's an obtuse angle, your calculator will not give you an obtuse angle. You learned about that in grade 11. That was called the ambiguous case. This is not an obtuse angle. Obviously, it's less than 40 degrees, so I'm not worried about that. I could use sine law, but it is generally more accurate for us to use cosine law because it always works. So I am going to use cosine law to do this. But I am not going to use this version of cosine law. I am going to use a rearranged version of cosine law that says that cosine of A is b squared plus c squared minus a squared, all divided by 2bc. Now, I don't have my yellow sheet in front of me right now, or do I? Wait a minute. I do. Who knew? Okay, here we go. It was in my drawer. All right, so these formulas, so the formulas for sine law, for cosine law for the side, and cosine law for an angle are all on your yellow sheet. You just have to look for them. Okay, so I have cosine A equals b squared plus c squared minus a squared over 2bc, right? That just came off of this formula sheet. So everything is already labeled for me, except it isn't really. The problem is that I'm not doing the same sides in the same places that I was last time. This time, we're not solving for A. I'm solving for B. So I don't really want to write my formula like this. Instead, I would like to start with B. And I would like to say that cosine of B equals, and then I do the other two sides. So a squared and c squared. And then minus b squared divided by 2ac. All I ended up doing was I swapped a for b. So everywhere I had an a, I put a b. Everywhere I had a b, I put a. So we basically just switched a and b in the formula, right? So everywhere I had an a, I put b. Everywhere I had a b, I put a. And the reason for that is because I'm looking for angle b, which is here, right? Not angle a, which I already know. Okay, so cosine of b, which I'm going to call x for now, is the magnitude of a. So that would be 5.2 squared plus c, which is, no, that was c. What did I write? All right, hold on. It is a up here, 11.67 squared, plus c, which is 5.2 squared, minus b, which is 7.2 squared, all divided by 2 times a, 5.2, times c. Why did I put those backwards? Why do I keep reading? I think I keep looking at vector a instead of the side a that I labeled. All right, I'm just going to put them in the opposite order here. As long as they're all in there, that's all that matters. So my apologies. I keep looking at vector a and not that this is side c and that's side a. All right, so I'm going to calculate my numerator and denominator separately. And I think I'm going to have to stop the video, and then we'll catch the rest of this calculation in the next one.